Hello everyone. In question with solution, today's question is from the chemical bonding topic. Actually, in NEET 2020, there was the two questions from this chemical bonding topic. One was on the dipole moment and second question is on the MOT, molecular orbital theory. So if we consider this question, now see here, identify a molecule which does not exist. This question is based on the MOT, and as we know that when we want to find out that molecule exists or not, there are some point. What is that point? Bond order. When bond order, what is the formula? Formula is bond order is equal to 1 by 2 NB minus NA. That is nothing but the number of electrons present in that bonding orbital and number of electrons present in the anti-bonding orbitals. Another one point is that when bond order is equal to 0, then that molecule does not exist. Clear to everyone? And third, very important point, here directly you will get answer if you are keeping in mind third point. Then what is that point? For the inert gases, that bond order is always equal to 0. Means if we consider helium 2, neon 2, their bond order will be equal to 0 and they does not exist in their molecular form. They are always present in their monoatomic form. Clear to everyone? So here directly we can say that our answer is option D or fourth option. Why? Because lithium 2, C2, O2 and He2. Here that is the inert gas. So hope so you have completed this point. How and why these are not the answer, that also we'll discuss in detail. So firstly you should know that some tricks. What are the tricks? Listen carefully. For the boron, carbon, nitrogen, when we are writing the molecular electronic configuration, at that time we have to keep in mind that 2 1 2 1. When we are going to discuss about the molecular electronic configuration of oxygen, fluorine, neon, at that time we have to keep in mind that 1 2 2 1. Now what did it means? Now see here. In case of boron to neon, up to that, in that electronic configuration 2p orbital get involved, and in that 2p there are the total 3 orbitals are there with py and 2pz. For 2px and 2py they form the pi, and here it is sigma 1. So if we consider first one, what is that first one? For the B2C2 and N2 molecule, for that one we are going to consider 2. Means here pi 2px is equal to, means pi 2px and pi 2p pi having the same energy. So if you observe that diagram, in that you can see that there are the two boxes we are drawing, and that is nothing but the 2px is equal to 2py, means both are having the same energy, while after that only one box we are drawing, means sigma 2pz having the greater energy than this pi. What about this one? Here in case of the 2 1 1 2, in that sigma 2pz having the lower energy, while pi 2p than pi 2px and pi 2py. Clear to everyone? And this common part 2 1 2 1. What about this one? In that we can say that pi star 2px having the same energy with the pi star 2py, but they having the less energy than the sigma star 2pz. So what is the use of this? That we will discuss here. Now we have to write the electronic configuration of this first 3, because finally we got the answer. According to that also you can solve it. So first one is the lithium. Now see, when one lithium atom combine with another one lithium, there is a formation of a lithium 2. Lithium, its atomic number is 3, means 3 electrons combines with the other 3 and there is a formation of a 6 electrons. What will be the electronic configuration? That will be 1s2, 2s1. So what will be the molecular orbital electronic configuration? That will be sigma 1s2, sigma star 1s2. Next one, sigma 2s2. So this is the electronic configuration. Now see bond order. If we want to find out the bond order, 1/2 number of electrons in the bonding orbital. How to identify? If star is there, then it is the anti-bonding. Without star, that is the bonding. So here we can say that number of electrons present in the bonding orbitals, that is the 4, minus number of electrons present in the anti-bonding, that is the 2. So here 1/2 into 2, that is nothing but the 1, means that molecule exists. Clear to everyone? So this is the first one. What about the second? What is that second? Carbon, C2. For that one, what is the our hint? Hint is that 2 1 2 1. So in that way, carbon plus carbon, it forms C2. Carbon, its atomic number is 6. Electronic configuration will be 1s2, 2s2, 2p2. Clear to everyone? Now we are going to write the molecular electronic configuration. So what will be it? That will start with the sigma. Here we can write the kk. That kk means sigma 1s2, sigma star 1s2. Clear to you? So if we are not writing, doesn't matter. Now see sigma 2s2, sigma star 2s2. So here we have completed 2 plus 2 4, 4 plus 4 8. Total number of electrons are 12. Now whose number will be there? That is of the 2, means pi 2px. Here 2 electrons are there. Firstly 1 electron will be here. After that pi 2p pi, 1 electron will be here. So in this way 4 plus 4 8, 9 10 will get completed. So again we have to fill 1 electron in that. So this is the electronic configuration, molecular electronic configuration of the C2 molecule. So if we consider the bond order, in that we can say that bond order 1/2. Number of bond pair electron, we are not taking part of this one. So 2 plus 2 4, 4 plus 2 6, minus how many antibonding electrons are there? Only 2. So here 1/2 into 4, that is nothing but the 2, means C2 molecule exists. Clear to everyone? So this is the way to complete the electronic configuration and to identify bond order is 0 or it is non-zero. If it is 0, that molecule does not exist. So here we have completed our second point, second option. Now what about the third one? Third one is of the O2. That will be the opposite to this one. So what will be there? Now see, oxygen atom combined with oxygen, it forms O2. Oxygen atomic number is 8. Electronic configuration will be 1s2, 2s2, 2p4. Now see here. So I am writing here directly kk, sigma 2s2, sigma star. After that, whose number is there? Now see here. Here for this oxygen, we have to keep in mind that 1 2 means here it will come sigma 2pz with the 2 electron, and after that pi 2px. After that pi 2py. Now see electron. How many are completed? Here 4. Here also 4. 4 plus 4 8. 9 10. 10 completed. How many remain? Total number of electron are 16. So here 2 will be there. 2 will be there. Again 4 will be added. 4 4 plus 8 10. It is 14. Next one, who's that number? Next number is of the 2 1, means it will be pi 2px, but that pi is star anti-bonding. So 1 electron will be in the 2px while second electron will be in the pi star 2py. So here also again 2 electrons completed. Why I have filled only 1 electron? Because both are having the same energy. And as we know that our Hund's rule, that according to that Hund's Pauli's exclusion principle as well as above principle, we have filled these electrons. So if we consider that bond order will be 1/2, that we are not going to consider. Now see here, that we have calculated for the electronic configuration purpose. For the bonding, here 2 plus 2 4, 6 7 8. So 8 minus how many electrons are in the antibonding? 2 plus 2 means total number of antibonding electron are 4. So here 1 by 2 into 4. Here again answer is 2. So we can say that oxygen molecule also exists. So here we have completed third one. What about the helium? Now I will explain here only. So if we consider that helium molecule formation will takes place He2. That formation will takes place when helium combines with the another one helium, which is not possible, but for the understanding purpose. As we know that helium, its atomic number is 2, so its electronic configuration will be 1s2. Molecular electronic configuration, that I am going to write here, and that molecular electronic configuration will be sigma 1s2 sigma star 1s2. That is the molecular electronic configuration. Now see here, bond order. Bond order is equal to 1 by 2 into number of electrons present in the bonding, that is 2. Number of electrons present in the anti-bonding, that is 2. Means here 1 by 2, 2 minus 2, 0. And here final answer is 0. So as I told you in the beginning only, when bond order is equal to 0, then that molecule does not exist. And that is true for the inert gases specifically. Clear to everyone? Another one concept I will tell you in case of the oxygen. Here in case of the oxygen, these electrons are unpaired. So oxygen is paramagnetic. In case of carbon, electrons present in the molecular orbital all are paired. So it is the diamagnetic, and oxygen is paramagnetic. Hope so everyone has completed each and every concept. If you have any doubt, you can write in the comment box. Thank you all of you.